Hi everyone, this is section 3.3 and we are going to talk about how to divide polynomials today. And I'm going to do it a couple of different ways at times and introduce a theorem as well. And we will just kind of jump right in. So the first example that I'm going to do, I will do two different ways. And I'm going to do this one longhand. And then I'm also going to do a shortcut method called synthetic division, and I'll show you how that works as well. So first of all, longhand, that means we're going to be doing some long division, just like if we were doing digits. So we're going to be taking this thing divided by this. So that means this guy is going to go inside our box, and we do want to write this in decreasing powers of x to make our life a little easier. And then we will divide this by that x minus 4. Kind of like when we write a number, we write our hundredths and our tenths. Like if we write the number 463, we leave it as 463. So 4 hundredths, 6 tenths, and 3 ones. We don't mix up the digits. So we want our highest powers of x to start. Longhand division is just tedious, and it is sometimes long. That's why it's called long-handed. But what we're going to do is we're going to take this first variable here, this x, and we're going to take that and say, okay, how many times does x go into 6x squared? Or what do I need to multiply x by to turn it into 6x squared? And the answer to that is I do need a 6 to create the 6 there, and I need another x. Okay, now I'm going to take this 6x and I'm going to multiply it times this whole thing. So we'll have that 6x squared, and then the 6x times that 4 is going to give us this negative 24x. Now we want to subtract. I'm not real good at subtracting, so I always kind of distribute that negative or that subtraction in. So I'll change my signs. I write them a little bit above, and then I add. Because for me it's easier to add. You'll notice these will disappear. And here we will get a negative 2x, and then we're going to bring down our next term. Similarly, when we do long division, we subtract, and then we bring down our next digit. And then we do the whole process all over again. We're going to take that x into the negative 2x, or what do I need to multiply x by to turn it into a negative 2x? And that would be a negative 2. Again, we're going to multiply both by both terms. So negative 2x plus 8. Again, we want to subtract, so I change my signs. And I add, so this gives me a positive 4. So here is my remainder. Okay, so this, when I take this guy divided by this, I will come up with 6x minus 2 with a remainder of 4, which we will write as, I'm going to put a plus if this, because it was positive. I could put minus if it was negative, and I will write 4 over x minus 4. Very similar to something like 7/3. If I did that long division, so I'm taking 7 divided by 3, goes in there 2 times, 6, and we get the 1 remainder. We would write this as 2 and 1/3. So the remainder over what we were dividing by. So similar ideas. And there is a little plus sign here. So this is 2 plus a third, 2 wholes plus a third of another one. So this is my whole part plus the remainder over that. Now, synthetic division is a little bit faster method. We don't have to deal with all of the x's and the x squares and everything like that. But we do, in this case, is we would take, and we're going to put, I usually put the 4 in the box. So we want to divide by an x minus an a. So whatever this minus is, so thinking of zeros from like when we were talking about polynomials before, the 0 would have been that 4. So that's going to go in here. So we're dividing by x minus 4. So the 4 is going in here. And what we're dividing in is we're going to pull just the coefficients of all of our pieces. So our x squared piece, our x piece, and our constant piece. If we were missing a power of x, we would have to put that 0 holder in our list of pieces. And I will go through an example of that later. The way synthetic division works, and I'll write synthetic on here, synthetic division. And it is only used when we're dividing by an x minus 8. Does not work if there's a coefficient in front of the x. Only works if it's a single x value. My cat just got in the way. Throw her down. All right, the way this works is I'm going to put a line here. We bring the 6 down. Okay, so the 6 just falls down. Then what we're going to do is we're going to take the number here and we're going to multiply. So 4 times 6 is 24. And then we add. This guy times this is a negative 8. And we add. Okay? Then what I like to do is kind of pull off that last piece. This is our remainder. So then we can take our answer and we just go up backwards. So this is our constant term, our x term, and if we had more, x squared, x cubed, and so forth. So when we take that 6x squared minus 26x plus 12 divided by that x minus 4, we will get our 6x minus 2 plus that 4 over what we were dividing by. Of course, we got the same answer. Okay, but synthetic division a little bit faster, and I like it because we don't subtract. I'm better at adding, as most people are. So we multiply and add, multiply and add. Okay, I do want to throw in a little bit of a remainder theorem here for us. And the remainder theorem is kind of a, I don't know, kind of a cool result, I guess. And we'll show that it works. So the remainder theorem says if we have a polynomial, if the polynomial p of x is divided by x minus c, so in this case we did x minus 4, then the remainder that 4 that we got, so there was our remainder, that 4, is the value p of c. Wow. So in other words, here was my polynomial that we just did. P of x was this 6x squared minus 26x plus 12. P of 4, which is what we were dividing by, if I put 4 in there, I'm going to have to do a little bit of work here. I'm just going to show you that it does work. Okay, so I take 4 squared, which is 16, and I multiply that by 6. I'll write all the numbers down here for us. So we get 96 minus 104 plus 12. So 96 minus 104 plus 12 gives me 4, which was our remainder. Wow. Where this is useful, or where we'll use it more, if c is a 0 of our polynomial p, this is only true x minus c is a factor. And we kind of knew that. We had already said that before, that a 0, we have the factor, but we can also notice that our remainder now, when we do this division, will also be 0, because by this remainder theorem, the remainder is going to be what the value is. So this is how they actually prove this little piece. Okay, I think I have time for another long division. Actually, I think I'm going to stop this video and we'll come back with another one. Just another long division and a couple more synthetic, another synthetic, just so that I don't run out of time. So I'm going to